later. Okay, so StatQuest, StatQuest, live stream. Hello, and welcome to Statland. Whenever we go to Statland, our friend makes a bet. I bet you $1 that the next person we meet loves candy and soda. So here's a question for the chat, and I've already seen a lot of good stuff there. Someone put smiley stat. I think that's good. Okay, so here's the question. What's the name? This guy, this smiley face is going to be showing up in a lot of our probability StatQuest, so we got to give him a name. And I was thinking stat man, stat person, Herman, or the guy with no body. But I've seen some funny things over in the chat. So just put something there. If you have a good idea, we could call him Mr. Double Bam. Or Mr. I'm about to lose a bet. But if you have any thoughts on what we should call this guy, give him a name, put it in the chat, and I'll review that afterwards, and we'll maybe we'll do a vote on online later. I'll do a poll maybe in Twitter or something like that, and we can vote on the best name. Okay, moving on. This is not the most important part of the video, by the way. Okay. Anyway. Since Statland is a small place, I asked everyone, represented by a colorful dot, if they loved candy and or soda. 6 people said they loved candy. And 7 people said they loved soda. And of the people that loved candy or soda, 2 people said they loved both. And last but not least, 3 people in Statland said they did not love candy or soda. All in all, there are 14 people in Statland. Okay, one way to keep track of this data is to put it into something called a contingency table. The rows are for keeping track of people that love soda or do not love soda, and the columns are for keeping track of people that love candy or do not love candy. We put the 2 people that love candy and soda here, and the 4 people that love candy but do not love soda here. And that means that 2 plus 4 equals 6, so 6 people in this column are the 6 people who love candy. Likewise, 5 people who love soda but do not love candy go here. And that means the 2 plus 5 equals 7, so there's 7 people in this row, and they are the 7 people who love soda. Lastly, the 3 people that do not love candy or soda go here. And that means the 4 plus 3 equals 7 people in this row are the 7 people who do not love soda. And the 5 plus 3 equals 8 people in this column are the 8 people who do not love candy. So we can use this picture to see who loves and doesn't love candy and popcorn in Statland. Or we can use the contingency table. They both contain the same information. Someone in the chat just said they love soda too. I wonder if they're from Statland. Anyways, bam! Okay, now remember that bet that our friend that we're still trying to name, they wanted to make this bet. They said, I bet you $1 the next person we meet loves candy and soda. So using the data from this fancy multicolored diagram or this crazy Technicolor table, we can calculate the probability of meeting someone who loves candy and soda. The P in this fancy statistics notation is short for probability. So this whole thing says the probability that someone loves candy and soda equals, and what it equals is the number of people that love candy and soda, 2, divided by 14, the total number of people in Statland. In other words, the probability that we will meet someone who loves candy and soda in Statland is the proportion of people that love candy and soda. And when we do the math, we get 0.14. And that means the probability that the next person we meet in Statland, the probability that they like candy and soda is pretty small. So we might take up our friend on his bet, and there's a good chance we'll win that $1. So once we give this guy a name, maybe he'll owe us $1. Bam! Now let's put the probability that someone loves candy and soda in our table so we will remember it. Note, we can put 2 divided by 14, or you can put 0.14 in the table since they're both equal. I'm going to put 2 divided by 14 in the table because it will help make things clear later on. Okay, so likewise, we can calculate the probability that somebody loves candy and does not love soda. We put 4 in the numerator because there are 4 people that love candy but do not love soda. And just like before, we put 14 in the denominator because there are 14 people in Statland. And that means the probability that someone loves candy but not soda is the proportion of people that love candy but not soda. Now we just do the math and we get 0.29. And we put that probability in the contingency table so we can keep track of it. Likewise, the probability that someone loves soda but not candy is 5 divided by 14, which is 0.36. So we add that to the contingency table, and the probability that someone does not like candy or soda is 3 divided by 14, which is 0.21, and we add that to the contingency table. Bam! We've got all the probabilities worked out for the contingency table. If we add up the probabilities, beep, boop, beep, boop, we get 1. And that just means that when we run into someone in Statland, there's a 100% chance that they will either love candy, love soda, love candy and soda, or not love candy and not love soda. So when the probability equals 1, we just know something's going to happen. Bam. Note, we can also determine the probability that someone loves soda regardless of how they feel about candy. We simply add the 2 people that love candy and soda to the 5 people that love soda but not candy, and divide by the sum 14, and divide the sum by 14, the population of Statland. This tells us that half the people in Statland love soda. Likewise, we can calculate the probability that someone does not love soda by adding up the counts in the second row and dividing by 14, the population of Statland. Then we can calculate the probability that someone loves candy by adding up the first column. And we can calculate the probability that someone does not love candy by adding up the second column. Bam! Now, what if we heard that pop sound as someone opened a bottle of soda or a can of soda? Whatever you have in your region, if you have cans or bottles, just imagine that sound. That sound would tell us that the next person we meet will love soda because they've just popped open a soda. Now, knowing that the next person we meet will love soda, what is the probability that the next person also loves candy? In other words, what is the probability that someone loves candy and soda given that we know they love soda? Note, in fancy statistics notation, we use this vertical line to mean given that. So this is the probability that someone loves candy and soda given that we know they love soda. Oh no, it's the dreaded terminology alert. Statisticians call this a conditional probability. So they would say that this is the probability someone loves candy and soda, given the condition that we know they love soda. Small bam. Okay, note, I hate using abbreviations, but let's let candy equal C, beep, and soda equal S, beep, beep. Okay, and earlier, we calculated the probability that someone loved candy and soda, but without already knowing they loved soda. And that was 2 divided by 14, or 0.14. So that's what we did when we had no knowledge about whether or not they loved soda or not. And because we didn't already know that they loved soda, the denominator consisted of the total number of people in Statland, 14. In contrast, now that we know the person loves soda, we can focus our attention on just the 2 plus 5, which equals 7, so 7 people that love soda. Because that's all we're talking about at this point. So, just like before, there are only 2 people that love candy and soda, so we put that in the numerator. But now, since there are 2 plus 5 people who love soda, we put that in the denominator. And that means the probability that someone loves candy, given that we know they love soda, is 0.29. Note, the probability is different from the original probability that was calculated without knowing whether or not they liked soda. So those 2 probabilities are not the same. In this case, knowing that they loved soda increased the probability that they would love candy, because 0.29 is greater than 0.14. Double bam! Okay, so now let's see what happens when we calculate the probability that someone doesn't love candy, given that we know they love soda. Using the fancy statistics notation, we have the probability that someone does not love candy and they love soda. I guess you could say but they love soda. Given that we know they love soda. Since there are 5 people that love soda and don't love candy, we put 5 in the numerator. And since there are 2 plus 5 equals 7 people who love soda, we put that in the denominator. And that means the probability that someone does not love candy, given that we know they love soda, is 0.71. And again, knowing that someone loves soda changes the original probability. The difference comes from the fact that originally the denominator included all 14 people in Statland. But once we knew they love soda, or once we know they love soda, let's keep my tenses correct, we know we only have to put 7 people, or the 7 people that love soda, in the denominator. Okay, now to make a little bit more room, let me move this up a little bit. Beep. And now let's divide the numerator and the denominator by the total number of people in Statland, 14. So if you look at that, all we've done is we've divided the 5 in the numerator, we've divided that by 14. And that 2 plus 5 in the denominator, we divided that by 14. No big deal. Now when we do the math, we get 0.71, which is the exact same conditional probability that we got before. And that makes total sense, right? When you divide the top and bottom by the exact same number, nothing changes because you're essentially dividing by 1, because that number will cancel itself out. So we really have done nothing to the equation. So what's the big deal of dividing everything by the total population? Why would I do that? Doesn't make any sense, or does it? Tune in for the next slide. When we divide the numerator and the denominator by the total people in Statland, 14, the numerator is now the original unconditional probability that someone in Statland does not love candy but loves soda. So we're going to move that up and we're going to place it with that probability statement. So we've got probability that someone does not love candy and they love soda. Bam. In the denominator is the unconditional probability that someone in Statland loves soda. We already calculated that before. 2 plus 5 divided by 14. And that means the denominator is just the unconditional. I guess I already said that, or maybe my slides are out. This always happens when I do a StatQuest live. There's always something. Anyways, that's the something, I guess. Hopefully that's the only something. Anyways, so we can replace that with the statistical statement of the probability that somebody loves soda. Okay? All in all, the probability that someone does not love candy but loves soda, given that we know that they love soda, is equal to the probability that someone does not love candy but loves soda. So this is the left side of that conditional probability divided by the probability that someone in Statland loves soda. So this is the right side of that conditional probability. No big deal. And when we do the math, we get 0.71. So now we can calculate conditional probabilities with raw counts or original unconditional probabilities. And the reason why using those original probabilities where we're not just plugging in numbers is because it's sort of like having an equation where you've got y equals 3 plus 2x. That the fact that we don't already have a value for x and we can plug in future values into x means we've got a flexible system that we can kind of change as we need it. And it's not locked down to any specific data set anymore. So when we have it in this notation, it's kind of general and can be applied not just to Statland, but to Stat Continent or Stat World or Stat Solar System or Stat Universe. So when we have this general equation, it's just a little bit more flexible and we can change the data set and still calculate our probabilities. Okay. Now that we understand conditional probability, the next step is Bayes' rule, and that's the foundation of Bayesian statistics. So we're going to give that a triple bam. And since we're done a little early, we're about 6 minutes early, what we're going to do is we're going to cut back to me. Hello. And I'm going to go over and I'm going to look and see if we got any questions that I can answer real quick in the chat room. So let's see what we got over here. We got people from all over. We've got different names for our BAM guy. Some guy said BAM Bud, and some guy said Mr. Bammerly. We got Batman or Statman. Someone suggested Smirnov. I think that's a good suggestion. Mr. Bam, that's a good one. Status Stallion. Ooh, that kind of sounds... I like the sound of that. Wilson, that's a good name. For anyone who's seen, what was that? Tom Hanks stranded on an island. What was that? Castaway. Statman, are you from DC or Marvel? Excellent question. Anyways, one question is, do I play tabla? And I will say, Not as well as I used to. I used to play tabla back in the day, and when I say back in the day, I mean a long time ago. And I wasn't even that good back then. I actually I'm a big fan. So here's a little history about me. When I was in high school, my parents, well, as soon as I graduated from high school, my parents moved to India. They moved to Chennai. Back then, it was called Madras, but the name changed a few years later, and now it's Chennai. Anyways, my parents moved to Chennai, and my dad taught biomedical engineering at the IIT, or the Indian Institute of Technology in Chennai. And he did that for a couple of years. Um, and I was here. I was in the United States, and I was taking, but for during the winter vacation, I would go to India. I'd go to South India, and I would spend my days learning how to play Carnatic and I guess Hindustani instruments as well. So I learned a little bit of tabla, but I also learned how to play the Carnatic Veena, which is a big, huge instrument made out of a jackfruit tree, and it's beautiful. And I love it because it has 4 strings. Look at my guitar. You see that my guitar only has 4 strings, and I just love instruments that have 4 strings. I also learned how to play an instrument that I do not know how to say in Hindi. The English translation, I believe, is beloved. I want to. Whenever I say it to an Indian person, they go, "What?" and they never understand what I'm saying, so I'm not going to say it. But it's a beautiful instrument, and I will show it to you real quick. This guy. This instrument. It's I haven't played this in a while as well. I mostly play my guitar. I also play the cello. Um, This is like a sitar. It's not a real sitar, and you play it with a bow instead of a pick. So it's related to a sitar. So anyway, if you guys know the name of that instrument, put it in the comments. That'd be great, or put it in the chat. Um, Anyways, that's the history of me and India. I haven't been there for a long time, and my goal for the next year is to do a small StatQuest tour of maybe the whole world, but I'd love to stop off in India while I'm at it. I know people all over the world love StatQuest, and I want to meet all you guys. To be honest, it flatters me and it makes me feel special. To know that there's people all over the world watching StatQuest, and I would love to come and do this in person for your school, for your whatever. And so that's sort of a long-term plan of mine is to do the stat tour. So, anyways, enough about me. That's my jibber jabber about India today. Just to remind you, in the month of May, I'm going to give you a heads up. There's going to be an announcement. We're going to do our first webinar where we go from start to finish. What do we call it? Machine learning. So I've got. We're going to take a data set. We're going to deal with missing data. We're going to normalize or standardize the data. We're going to build a machine learning algorithm. We're going to then optimize the hyperparameters, which sounds super fancy, but we're just tweaking some numbers. And then we're going to rebuild the thing, and we're going to print out cool visualizations of what we're doing. And at the end, you'll have the code and a Jupyter notebook that you can then play with on your own, or you can follow along during the webinar. And so that's going to happen in May. The other thing that's going to happen in May is the StatQuest study guides are going to become available. So we got 2 big things that are coming out in May, and I'm super excited about it. And I guess that's it for today. All right. Thanks for joining us. Until next time, quest on.